Hello, everyone. Welcome. And we are excited to be here to talk about KServe. My name is Yuan Tang. I'm a senior principal software engineer at Red Hat. I'm also one of the co-lead with Dan for the KServe project.
Hello, everyone. My name is Dan. So I lead the inference platform team at Bloomberg. I'm the co-founder of KServe, and I have been working with Yuan for a very long time on this product.
So what is KServe? KServe is a distributed, scalable, and standardized model inference platform on Kubernetes for both generative and predictive AI. First, I'd like to talk about our journey so far. So in 2019, KServe was developed as a project called KServing under the Kubeflow project. Everything was developed under Kubeflow, and it was such a joint effort by different companies. At that time, the project was still owned by Google. And in 2021, KServing got rebranded to KServe project in a separate organization, and we also released a first version that's standalone so that users can install it without Kubeflow dependencies. In 2022, KServe, as a new project, joined the LFAI and Data Foundation, and that was a super exciting moment because joining the foundation means that everything's becoming like vendor neutral, and we got a lot of more contributors coming in because of that. And here we are today. We are super excited to share that KServe has just joined CNCF as an incubating project. So yeah, thank you. Super exciting to be part of the big family, and we look forward to continue our collaboration and deepening our partnerships within the cloud-native community. Next, I'm going to pass it to Dan to talk about KServe in detail.
Yeah, as Yuan said, KServe has a pretty long history. We started back at 2019, and very additionally, we primarily focused on the predictive inference, and now in this Gen AI age, so we are targeting to make a KServe as a platform which can unify both generative and predictive inference workload on Kubernetes. So it simplifies the model deployment in Kubernetes environment, and also provide it's powerful enough to with all the building features the out-of-box serving runtime for both predictive and generative runtimes, and with building features like auto-scaling, inference optimizations, and authentication and monitoring. So made it very powerful to run at enterprise at scale level for all the AI workload with all the advanced features. In the starting from 2019, so at that time we were primarily working on making predictive inference running well on Kubernetes. It supports features like auto scaling based on requests volumes, batching requests, request response logging, and authenticating inference workload and managing the traffic at scale, and with all the building distributed tracing and monitoring metrics. So our approach at that time we were taking is to assembly all the CNCF components. So we use Knative for the auto scaling. We use Istio for the service mesh, authentication, authorization, as well as the traffic management, and of course the open telemetry for the tracing and the metrics. So this gave us the building this inference fortress and robust enough to running on at the production level. So now we add this additional dimension for this generative AI. So initially we were taking all the small, well-structured inputs and to make a classification or regression predictions. And now the inputs becomes a variable and a multimodal. So we generate code, we generate text, we generate images, we generate ideas. So it becomes a much more complex. And the latency, it also adds the latency becomes moderate to high, and and the output usually needs to be delivered in a streaming fashion because to improve the user experience. All this this creatively definitely adds a lot of complexity to our stack. So it transforms how we think we want to serving these large models and run at a scale. So the predictable workload we initially can run, we can horizontally scale on CPU and run small GPUs to maximize the performance. And now all these LLMs, which requires heavy computation and precious GPUs like H100, H200s with a high memory bandwidth. So we really want to ensure we can run this inference workload efficiently on GPUs, fully utilize the memory. So we really require advanced kind of these recipes to craft our AI inference for LLMs. We need, in order to scale, we need to have a precise autoscaler based on these LLM metrics, the KV cache utilization or GPU utilization metrics, to be able to not waste any of the GPU compute. For efficiency, we need this backbone, these runtimes, VRM, TensorRT, TRM, LLM-D, all these runtimes are the backbone for KServe to host these LLMs efficiently on GPUs. And prompt caching can help us reduce the cost. So we can save our compute by caching the KB results. So the following request can hit the cache and then can help save the GPU time. And intelligent routing, traffic management is critical in this space to further improve the latency and throughput. Because the LLMs are slow, and so we really want to make sure the routing are intelligent enough to leverage this caching and need advanced traffic management to ensure especially in a multi-tenant environment. So this is a high-level Gen AI architecture for KServe. So we have the KServe control plane has to orchestrate the single model, the LLMs, which can be deployed on single node or multi-node, multi-GPUs. So the control plane takes care of all the deployments, so make it really easy to deploy and host LLMs on Kubernetes environment. And we have model cache and can cache the model on each of the node. So make the autoscaler be really fast to react to the high inference workload. We also integrate well with the distributed KV cache or the LLM cache, which we can cache the KV results and then make lower the inference cost. And at the top, so we also work very closely with the Envoy community. So this is a very important a component which can do have the intelligent routing capabilities and manage the AI traffic support, for example, tracking the usage, relimiting, and have all the observability to to track the LLM metrics like TTFT, token throughput. So this gives you the full capability to manage the AI LLM inference traffic. We also integrate with the gateway APIs. So they can handle both the predictive and with the inference extension, we can also support the more advanced traffic in routing capabilities for LLMs. So some of the highlight features are the auto scaling. So traditionally, in the predictive inference workload, we use Knative as the default auto scaler. That is purely based on the in-flight request concurrency. However, and for LLM request, it is the concurrency means it tracks from at the moment the request is received until the first token is the last token is emitted. Right, so in this case, a single long prompt can fill all the GPU memories, and then however the autoscaler just needs concurrency one, so it may not be be able to react quick to scale based on your LLM inference workload. So the bottleneck will be GPU RAM, right? for the KV cache. So KServe offers this metrics, LLM metrics-based autoscaler. So you can like configure your inference service with the good metrics, which can scale based on your with the precise like the KV cache utilization. So one of the key metrics here is the KV cache utilization. And as your primary metrics, and the second, so you can like have configure like a list of like a metrics, be able to correctly predict your like LLM inference workload. So another important feature is the token limit, which is provided by the Envoy AI Gateway. So often the time, especially in the multi-tenant environments, so all your tenants is sending all the LLM requests to your gateway. So it's important to protect all your GPU resources if you have models hosted on-prem or like you have models hosted on cloud. So the way how it works is like we track the token usage from the LLM inference response. Usually the input-output tokens are sent in the response, and the cost is actually stored in Envoy, where we have the dynamic metadata, and which is integrated with the Envoy like a relimiter. So you can actually track the request. So if you have a tenant which like send a lot of like tokens, so you can prevent like that single tenant to use fully occupies all the capacity you have in your cluster. Another feature we recently implemented as part of 0.16 is we implement the inference extension standard from the gateway API. So this gives you the more advanced routing capability based on like, so you have many parts of your like LLM inference service, so this gives you the capability to select a part which is suitable for the routing. So usually when you like send requests, you know like where you want to know where your cache is located, right? So so you don't want to like send to a pod which is you need to recompute all the KV, which you already done in the previous request. So this is particularly useful for like a multi-turn like conversations, right? So you already have the system prompt already computed, and you don't want to like rerun those compute the KV cache again. And another example is the LoRa adapters. So LoRa, you can like use the same, you can host a single like a foundation model, and you can like host a lot of hundreds of LoRas on top of it. So you don't want to like for a single LoRa, you want to like host many of the foundation model and then just add the LoRa adapter on top. So in this way, you can like share the same foundation model, or like you can deploy like many lightweight LoRa adapters on top. So this can help you like save a lot of GPU resources. Next, I will hand over to Yuan to talk about the LLM-D integration.
Yeah, so one big feature is we added to the most recent release, the KServe 0.16 release, is the LLM-D integration. This is something we've been working on with the LLM-D community for a while. So what is LLM-D? It's an open source framework for running LLM inference that runs natively on Kubernetes. It's a joint effort by many different companies, including some of the major vendors. So what does the integration provide, right? So the first one is the intelligent inference scheduler, which helps make routing decisions based on metrics that you collected from like whatever metric server you are using. And based on those metrics and different scoring and filtering algorithms, it will make the routing decisions intelligently that takes into account for like load, KV cache, and PD disaggregation, and so on. And the prefix caching feature, which helps offload the KV cache to either host or remote storage, or even like third-party systems like LLM cache. And the third feature is the PD disaggregated serving, which allows you to optimize and deploy your prefill and decode instances independently, because sometimes there are two different phases: the prefill and decoding phase for LLM inference, where the prefill phase is more compute intensive, while the decoding phase is pretty memory bound. So they have really different computational profiles and demand. So by disaggregating these two different types of workloads, we can optimize the inference performance. And the last one is the variant auto-scaling feature that's actively being worked on by the LLM-D community. So we aim to provide an auto-scaler that can auto-scale based on different variants, including your different types of hardwares and different types of workloads and traffic and so on. So talking about different workloads, right? So the KServe, the LLM-D integration in KServe allows you to express different types of workloads. So the first one is a single node workload. This is a good fit if your model is small enough, like less than 70 B, and you want to run like a single instance, on everything on single node, like assuming your models fit on that single node. There's no distributed parallelism, and it's very suitable for smaller models. And multi-node workload is more for larger models that don't fit on a single node. And in that case, we'll deploy like leader worker set instead of like Kubernetes deployment. And you can also specify different parallelisms, including tensor parallelism, data parallelism, and so on. And it's best fit for large language models. And we can also express disaggregated workload by specifying different computational requirements for prefill and decode. And KServe while ROA will spin up different like leader worker set deployments for you automatically that actively uses the KV cache and other things to optimize the performance. So here's the control plan for the LLM inference service that's recently added. Like this is the main CRD main entry point if you want to use LLM-D in KServe. It includes multiple specs. For example, the model spec, which is where you specify the model name, where to download the model, the priority or how critical your model is, right? And you can also specify like your LoRa adapters and so on. And based on that specification, KServe will automatically pull the model for you from different sources. The second spec is the router spec, which is responsible for creating gateway-related resources, including gateway, HTTP route, or inference pool. And the third one is the template spec, which allows you to specify different types of workload, including the single node, multi-node, or disaggregated serving, as we mentioned in the last slide. And it will create different resources, including raw Kubernetes deployment or leader worker set based on whatever workload you specify. And you can also specify different parallelism, including tensor parallelism, data parallelism, as well as expert parallelism. So this is the data plane for like running LLM inference through the LLM-D integration in KServe. So basically, like the gateway first receives the inference request from the users. That serves as the main entry point. And the HTTP route matches the path and the endpoint, the API endpoint. And if a scheduler is disabled, a Kubernetes service will be used and will utilize whatever is available in Kubernetes, like the native load balancer from Kubernetes. And if a scheduler is enabled, we'll spin up a separate endpoint picker pod, which is responsible to query from the inference pool that contains like different types of parts, including like prefill and decode, and it will select the parts based on metrics, different scoring and filtering algorithms, and the workload you specify. So through the intelligent endpoint picker, we can route the request based on prefix cache or like your PD disaggregation pool, and it's also aware of the workload. I'll hand it over to Dan to talk about the roadmap.
So the next step for the KServe is, so we just released the 0.16 this week, and then the target for next in the future release will be focusing on the unified inference fabric, and of course we'll get the LLM inference service the offering more mature, and once that is done, then we will get this provide a centralized platform for both predictive and generative inference. I know there's a lot of excitement about the LLM, but I think that the predictive inference at the same time is not going away. There are still a lot of use cases like time series, which does not apply to LLMs. So our goal is still to provide a unified platform for everyone, for all the inference use cases, and working on the standards API for gateway APIs, data plan, both on the both control plan and data plan, and have the same telemetry system for the consistency. At the same time, we also want to provide a fully managed inference experience with building optimize the performance, so people don't need to run benchmarkings or currently there's still big gap where people can still tune a lot of parameters to get the desired performance. I think in the future we want to make this experience also out of the box. And I think Yuan also have the keynote tomorrow to talk about the security identity, how the agent will be interact with the LLM traffic. So stay tuned for tomorrow's keynote. So this is a kind of a diagram where the future will look like. So we have to handle both the LLM and predictive inference. So we have kind of two data plan APIs to. We still support the previous open inference protocol for the traditional workload, and also the chat completion embedding for the Gen AI workload. So they will go through the same gateway, use all the gateway API, and for the more intelligent advanced capability, we'll use the inference extension to be able to intelligently route to select the best part, which video request. So this gives you a unified experience to have a single unified user experience for your inference story. Talk about the community.
Yeah, last but not least, I want to talk about the community, right? So KServe won't be where it is today without the amazing group of community of contributors and maintainers. So we want to thank you for everyone who've contributed to KServe along the way. And it's so amazing to see so many organizations and community members adopting KServe. They are either end user companies or vendors behind the scenes. So if you are ever using KServe, feel free to add yourself or your organization to the adopters list and share your story with us. And join our community. So we have our GitHub repo link, and the QR code is available that will redirect to the GitHub repo. And the website link is here. We do host community meetings every other week on Thursdays. If you want to join us and discuss your ideas, or we can share any ideas with you on how to get started contributing. And we also have two Slack channels. One is the user-focused. The other one is contributor-focused. Both are on the CNCF Slack. Yeah, that's it. Thank you.